Space isn't just a vast, empty void. It's a cosmic puzzle box filled with secrets that twist our understanding of reality itself. What if everything we think we know about the universe is just the tip of the iceberg? From black holes that might be gateways to other dimensions to invisible forces shaping the fabric of existence, the cosmos is teeming with theories so bizarre they feel ripped straight from science fiction. But here's the thing, these aren't fantasies. They're real ideas backed by cutting-edge science, and they're about to flip your perception of reality upside down. Over the next few minutes, we'll uncover 25 of the most mind-bending space theories that challenge the very foundations of what we thought we knew. Buckle up, this journey is going to stretch your imagination to its limits. What if everything around us, the stars, the planets, even your own thoughts, isn't real? Not in the way we think, at least. That's the core of the simulation hypothesis, a theory suggesting our entire universe might just be an incredibly advanced digital construct. Think of it like the most immersive video game ever made, except with the characters unaware of the code running behind the scenes. Tech visionaries like Elon Musk have openly speculated about this, pointing out how rapidly technology evolves. So why couldn't an ultra-advanced civilization have already achieved this? Philosopher Nick Bostrom takes it further with his trippy simulation argument, suggesting it's statistically more likely we're living in a simulation than in base reality. But it's not just thought experiments. Quantum mechanics throws fuel on the fire. Particles that exist in multiple states until observed, that could just be the simulation conserving processing power. And those eerie glitches in the matrix, like déjà vu or impossible coincidences, might they be tiny bugs in the system? Of course, skeptics argue there's no solid proof, just intriguing possibilities. But whether you buy into it or not, the simulation hypothesis forces us to ask, if reality isn't what it seems, how would we ever know? Hold onto your seats, because what if the universe you see around you, with all its depth and dimension, is actually an illusion? Enter the holographic principle, one of the most radical ideas in modern physics. It suggests our three-dimensional reality might just be a projection, like a cosmic hologram, encoded on a flat, two-dimensional surface at the edge of space. This isn't just wild speculation. The theory traces back to black holes, those cosmic enigmas that warp space and time. When matter falls into a black hole, what happens to the information it carries? According to quantum mechanics, information can't be destroyed, yet black holes seem to erase it. That's the paradox, but in the 1990s, physicist Leonard Susskind proposed a jaw-dropping solution. The information isn't lost. Instead, it's smeared across the black hole's event horizon, like a celestial DVD storing data on its surface. Now, take this idea and scale it up. If black holes encode information in two dimensions, could the entire universe work the same way? Some physicists argue yes, that everything we perceive, from distant galaxies to the phone in your hand, is essentially a 3D projection of data written on a hidden, flat boundary we can't see. It's like reality is an IMAX movie playing on the universe's ultimate screen. Even stranger, this could explain why the universe seems pixelated at the smallest scales. Just as a hologram becomes blurry when you zoom in too far, space-time might reveal its true, grainy nature when examined closely. Experiments with gravitational wave detectors and quantum entanglement are now hunting for clues, tiny ripples or anomalies that might betray the universe's holographic secret. So is reality just a shadow of something deeper? The holographic principle blurs the line between science and philosophy, forcing us to rethink what real even means. Whether it's true or not, one thing's certain: the universe just got a lot weirder. Here's something to scramble your brain. What if you aren't even real? Not in the way you think, anyway. Meet the Boltzmann Brain, a theory so bizarre it makes the simulation hypothesis seem almost comforting. Picture this: in an infinite, chaotic universe governed by entropy, the slow march toward disorder, random fluctuations could, by sheer accident, conjure up a fully formed, self-aware consciousness. No body, no history, just a lone brain floating in the void, hallucinating an entire reality into existence. This isn't just cosmic paranoia, it's rooted in thermodynamics. Ludwig Boltzmann, the 19th century physicist, showed how entropy drives systems from order to chaos. But given enough time, even in total disorder, tiny pockets of order can spontaneously appear. Now stretch that idea across eternity in an endless universe. Statistically, it becomes more likely for a single, self-aware mind to pop into existence out of nowhere than for an entire, structured cosmos like ours to emerge. Some scientists argue uncomfortably that Boltzmann brains should outnumber real, evolved minds, meaning you're probably one of them. Why doesn't this sit right? Because if consciousness is just a fleeting glitch, then everything, your memories, the stars, even the laws of physics, might be an illusion. Critics fire back that the universe's structure and consistency make Boltzmann brains absurdly improbable. But here's the twist: the very fact we're having this debate might be the best evidence against it. A random, momentary brain wouldn't ponder its own existence, it'd just flicker out. So maybe, just maybe, reality really is as solid as it feels. Or is that exactly what a Boltzmann brain would think? Black holes devour everything: light, matter, even time itself. But what if their cosmic opposites exist? Enter white holes, the hypothetical yin to black holes' yang. While black holes suck everything in, never letting go, white holes would do the exact opposite, violently spewing out matter and energy, a cosmic fire hose blasting material into existence. And here's where it gets wild. Some physicists speculate these elusive white holes could actually be the birthplaces of entirely new universes. The math behind this is mind-bending. Einstein's equations allow for white holes as a valid solution, just like black holes' mathematical twins in a way. But while we've observed black holes warping space around them, white holes remain purely theoretical. Yet, if they do exist, they wouldn't just eject random debris. Some theories suggest the material pouring out could be so dense, so packed with energy, that it triggers its own Big Bang, creating a brand new universe with its own laws of physics, completely separate from ours. Think of it like a cosmic Russian nesting doll. Our universe might have been born from a white hole in some other universe, and in turn, black holes in our own cosmos could be spawning entirely new realities inside them. This ties directly into the multiverse concept, where countless universes bubble up, each with its own unique conditions. Some might have stronger gravity, others might not even have stars, endless variations spawned by the explosive fury of white holes. Of course, skeptics argue we've never detected one. After all, if a white hole only expels and never absorbs, how would we even observe it? Maybe they're hidden in plain sight, cosmic ghosts flaring briefly before vanishing. Others suggest white holes could just be black holes in reverse time. Imagine rewinding a black hole's life. Instead of collapsing inward, it explodes outward. Time symmetry in physics allows for this, but whether nature actually does it remains a tantalizing mystery. One thing's certain: if white holes are real, they rewrite the story of cosmic origins. The universe we know might just be one branch on an infinite tree of realities, all birthed from the violent, radiant death throes of something we can't even see. We think of the Big Bang as the ultimate beginning, a single, fiery moment where everything began. But what if that explosive birth wasn't the start? What if it was the echo of something far stranger? Some physicists now suggest our universe didn't emerge from nothing. It might have burst into existence when a black hole in another dimension collapsed. At the heart of this idea is a problem with the Big Bang theory itself. The equations break down at the moment of singularity, that infinitely dense, infinitely hot point where physics as we know it stops making sense. But loop quantum gravity, a cutting-edge framework trying to unite relativity and quantum mechanics, offers a radical fix. It proposes that space-time isn't smooth and continuous but woven from tiny, indivisible loops, like a cosmic fabric stitched together at the smallest scales. In this view, a black hole in some parent universe wouldn't just vanish into a singularity. Instead, its crushing gravity would distort space-time until the pressure rebounds. Like a spring coiled too tight, the collapse reverses into an explosive bounce, our Big Bang. Picture it as a cosmic phoenix. A black hole dies, and from its ashes, an entirely new universe ignites. This isn't just wild speculation. The math shows surprising parallels between black hole physics and the conditions of the early universe. Both involve incomprehensible densities, warped space-time, and a breakdown of classical physics. Even stranger, if black holes birth universes, then our own cosmos might contain countless others sprouting invisibly inside its black holes, an endless, branching multiverse. Of course, not everyone's convinced. Critics argue we lack direct evidence, and the leap from theoretical models to observable reality is enormous. But if this idea holds, it rewrites our cosmic story. The Big Bang wasn't the beginning, just a spectacular ripple in an infinite chain of universes, each born from the collapse of something older. It's a humbling thought. We might be living in the aftermath of another universe's death. What if the universe isn't just out there? What if it's thinking? At first glance, comparing the cosmos to a brain sounds like pure science fiction, but take a closer look and the similarities become unsettling. Galaxies cluster together in vast, interconnected webs, their filaments stretching across billions of light years, almost eerily mirroring the structure of neural networks in the human brain. It's as if the universe itself is wired like a cosmic mind. This isn't just a poetic coincidence. Studies have shown that the distribution of matter in the observable universe and the way neurons connect in the brain follow shockingly similar mathematical patterns. Both systems organize into nodes and pathways, exchanging information whether through electrical impulses or gravitational forces. Some scientists even argue that if the universe has structure, and structure processes information, then on some unimaginable scale, could it also harbor consciousness? The implications are staggering. If the cosmos is self-aware, does that mean it's observing us, or are we tiny, fleeting beings, just brief flickers in its cosmic thought process? Philosophers have toyed with this idea for centuries, but modern physics gives it new weight. The universe as a brain theory blurs the line between observer and observed, suggesting reality might not just exist but actively perceived. Of course, not everyone's convinced. Critics point out that similarity in shape doesn't equal sameness in function. Just because galaxies look like neurons doesn't mean they think like them. But if there's even a sliver of truth here, it reshapes everything. Are we merely passengers in the universe, or are we part of something far grander, a vast, unfolding thought in the mind of existence itself? The question lingers, hanging in the void like a whisper waiting to be heard. We know dark matter exists, or at least we know something does. It exerts gravity, bends light, and makes up most of the matter in the universe, yet we've never seen it, never touched it, never detected it directly. But what if the reason we can't find dark matter isn't because it's hiding, but because it's not from our universe at all? Imagine a parallel reality existing right alongside ours, separated by a thin, invisible barrier. Normally, the two universes wouldn't interact, but what if, in rare, fleeting moments, matter from that side slips into ours? That's the spine-tingling idea behind the shadow universe theory. The gravitational pull we attribute to dark matter might actually be the tug of particles from this invisible twin reality bleeding through the cosmic veil. This isn't just wild speculation. Some versions of string theory suggest our universe could be floating in a higher dimensional space, brushing against others like soap bubbles in a sink. If these universes occasionally graze each other, their matter could mingle, just enough to explain why we feel the gravitational effects of something we can't see. It's like hearing footsteps in an empty room. You know something's there, even if you can't turn the corner fast enough to catch it. The implications are staggering. If dark matter is foreign matter, then our universe isn't just expanding, it's leaking. Galaxies might be anchored by invisible anchors from another dimension, and the mysterious dark flow dragging clusters of galaxies in one direction could be the gravitational wake of a neighboring cosmos pulling on ours. Of course, not every scientist is convinced. Critics argue that without direct proof, this is closer to metaphysics than physics. But here's the twist. Experiments like the Large Hadron Collider are now hunting for exotic particles that could act as messengers between universes. If they find even a hint of a particle that shouldn't exist, a gravity anomaly with no explanation, the doors to the multiverse might just creak open. So is dark matter the ghostly fingerprint of another reality. The universe has a funny way of keeping its biggest secrets just out of reach, but the hunt is on, and the answers could rewrite everything we thought we knew. We've all felt time slipping through our fingers, seconds ticking away, days turning into years. But what if that relentless forward march is just an illusion? A trick of the mind. Some physicists argue time might not flow at all, that past, present, and future exist simultaneously, frozen in a block of eternal now. Take quantum mechanics, where particles behave in ways that make no sense if time is linear. In the famous double-slit experiment, particles appear to choose whether to act like waves or particles before being observed, almost as if they're peeking at the future to decide their past. It's like flipping a coin and watching it land heads before it even leaves your hand. This isn't just a quirky lab result. Einstein's relativity already shattered the idea of universal time, showing clocks tick slower near black holes or at high speeds. But if time bends, could it also not exist as we think? Some theories suggest our brains stitch together memories into a narrative, creating the feeling of time passing. Like a movie reel, reality might just be a series of static frames our consciousness animates. The implications are dizzying. If time isn't linear, then free will might be an illusion, every choice already made, every moment locked in place. Even death could just be a point in the block, not an end. Critics counter that our lived experience of time is too visceral to dismiss, but the math keeps pointing toward something stranger. So is time real, or just the universe's most convincing magic trick? The answer might rewrite not just physics, but what it means to be at all. We've gazed at the moon for thousands of years, tracing myths and marveling at its gentle glow. But what if it wasn't just a natural satellite? What if, against all odds, the moon is something far stranger? Some researchers point to a series of baffling anomalies that suggest our closest cosmic companion might not be what it seems. Start with its perfect eclipses, a cosmic coincidence so precise it defies probability. The moon is exactly 400 times smaller than the sun, but it's also 400 times closer. That's why, during a total eclipse, the moon fits over the sun like a glove, creating those awe-inspiring moments of daytime darkness. Statistically, the odds of this perfect alignment happening naturally are astronomically low. Could it be engineered? Then there's the moon's composition, or rather, its lack of it. Compared to Earth, the moon is unusually light. Its density is significantly lower, leading some scientists to speculate that it might be hollow, or at least contain vast, empty spaces inside. This theory gained traction after Apollo missions left seismic equipment on the lunar surface. When modules were deliberately crashed into the moon, it rang like a bell, vibrations lasting far longer than they should on a solid, rocky body. Even more puzzling, the moon's surface metals don't match Earth's. Elements like titanium appear in concentrations much higher than expected, almost as if its crust was deliberately reinforced. Some ancient astronaut theories take this further, suggesting the moon could be an artificial construct, a relic from an advanced civilization, placed in orbit for reasons we can't yet fathom. Of course, mainstream science pushes back. Most astronomers argue that these oddities have natural explanations, like the moon forming from debris after a colossal impact with early Earth. But the lingering questions remain. Why haven't we found a single other moon in the solar system that behaves like ours? Why does it seem to defy the usual rules of planetary formation? Whether you lean toward the extraordinary or the conventional, one thing's certain: the moon holds secrets we've only begun to uncover. And if even a fraction of these anomalies point to something artificial, it would rewrite not just lunar history, but our entire understanding of the cosmos. For centuries, the sun has been the steady, reliable heart of our solar system. Its warm light nurturing life on Earth, its gravity holding planets in place. But what if it's more than just a fiery ball of plasma? What if it's hiding something impossible? Some researchers propose the unthinkable, that our sun might not just be a star, but a portal, a cosmic doorway for beings or energies beyond our comprehension. Start with the baffling mysteries of the sun itself. Despite decades of study, scientists still can't fully explain why its outer atmosphere, the corona, is millions of degrees hotter than its surface. It defies logic, like a candle flame that burns hotter the farther you get from the wick. Then there are the bizarre UFO-like objects spotted near the sun in NASA SOHO images, anomalous shapes darting in and out of the solar corona at impossible speeds. Some appear to be massive, structured craft, dwarfing Earth in scale, yet they maneuver effortlessly through temperatures that should vaporize any known material. Could these be visitors from somewhere else, using the sun as a transit point? Ancient myths across cultures hint at this idea: deities and celestial beings emerging from the sun's brilliance. Even modern theories suggest advanced civilizations might harness stars as gateways, tapping into the immense energy of plasma to traverse dimensions or vast cosmic distances. The math gets wilder. If higher dimensions exist, as string theory suggests, the sun's intense gravitational and electromagnetic fields could twist space-time into temporary bridges, allowing passage between realms. Some even speculate that so-called solar beings might live within the sun's plasma, entities made of pure energy who use the star as both home and highway. Of course, skeptics argue these anomalies have mundane explanations: solar flares, camera artifacts, or undiscovered natural phenomena. But the sheer strangeness keeps the debate alive. If even a fraction of these theories hold weight, the sun isn't just our life-giving star. It could be the universe's grandest stargate, humming with secrets we've only begun to glimpse. The universe is unimaginably vast, teeming with stars, planets, and potential civilizations. So where is everybody? That's the Fermi paradox in a nutshell. If life is so probable, why hasn't it made contact? One chilling answer flips the question on its head. They're out there, watching us from the shadows. We might not be alone. We might be in a zoo. This is the zoo hypothesis, a spine-tingling solution to the great cosmic silence. The idea is simple: advanced extraterrestrial civilizations know we're here, but they're deliberately avoiding contact, observing humanity the way we'd study animals in a wildlife preserve. Think about it. Would you barge into a nature reserve shouting at the chimpanzees? Of course not. You'd watch from a distance, careful not to disturb their natural behavior. Supporters of this theory point to Earth's own history. Isolated tribes, uncontacted for centuries, often collapse when exposed to outside influence. If aliens follow ethical guidelines, they might see interference as harmful, choosing invisibility over chaos. There's also the technological argument. Any civilization advanced enough to reach us could easily cloak their presence, masking signals or probes with tech beyond our comprehension. But why wouldn't they reveal themselves? Some scientists speculate that every intelligent species hits a critical threshold, like nuclear war or climate collapse, and galactic observers might be waiting to see if we survive our own adolescence. Others suggest Earth could be under some form of quarantine, locked away until we evolve past violence or environmental destruction. Critics dismiss this as speculation wrapped in paranoia. After all, absence of evidence isn't evidence of absence. But the eerie silence does leave room for unsettling possibilities. If the zoo hypothesis is real, then the night sky isn't just empty. It's a one-way mirror, and something out there is quietly taking notes. The question isn't, are we alone? It's, what are they waiting for? You've probably experienced it, that eerie moment when you swear something happened a certain way, only to find out the world insists it didn't. Maybe you remember the Monopoly man wearing a monocle he never did, or Nelson Mandela dying in prison he didn't. These collective false memories aren't just quirks of the mind. They might be evidence of parallel universes brushing against ours. Welcome to the Mandela Effect, where widespread misremembering points to something far stranger than faulty neurons. Some theorists argue these glitches occur when alternate realities briefly overlap, allowing fragments of other timelines to bleed into our own. Think of it like radio static, two stations momentarily broadcasting at once, creating a scrambled signal in our memories. Take the infamous Berenstain Bears debate. Thousands insist the children's book series was once spelled Berenstein with an E, but dig through archives and it's always been A. Could this be a quantum hiccup, a moment when our timeline shifted, leaving only a ghostly residue of the old spelling in our minds? Even more unsettling, some scientists speculate that high-energy experiments like those at CERN could be inadvertently poking holes in reality. When particles collide at near-light speeds, they might create microscopic rifts in space-time, tiny doorways to alternate dimensions. While CERN dismisses this as fantasy, the timing of certain Mandela Effect reports does oddly coincide with their Large Hadron Collider test runs. Skeptics wave it off as confabulation, our brains filling gaps with plausible fictions. But the sheer consistency of these false memories across unrelated people raises questions. Why do so many misremember the same details? Why do these errors feel so real? Whether you chalk it up to psychology or parallel worlds, one thing's clear: reality might be far less stable than we think. And if universes are colliding, the next glitch could rewrite something far bigger than a cartoon bear's name. Picture reality as the most sophisticated computer ever built, except instead of silicon chips and code, it runs on the bizarre rules of quantum mechanics. This is the bold idea that our universe might be one colossal quantum computer, processing existence itself at the most fundamental level. At the heart of this theory lies quantum entanglement, a phenomenon Einstein famously called spooky action at a distance. When two particles become entangled, their states instantly sync no matter how far apart they are, almost like cosmic data packets linked by an invisible network. Then there's superposition, where particles exist in multiple states at once until observed, like a cosmic program holding all possible outcomes in memory until the result is needed. These aren't just quirks, they're the precise behaviors you'd expect from a universe processing information. Think of space-time as the hardware and quantum events as the software operations. Every collision, every chemical reaction, even your thoughts, could all be computations in a grand cosmic algorithm. This gets wilder when you consider the fine-tuning problem, the uncanny precision of the universe's constants. Gravity, the speed of light, the charge of an electron, if any of these were slightly different, life couldn't exist. It's as if reality's parameters were meticulously coded to allow complexity to emerge. Some scientists argue this precision points to a programmed universe, one where the laws of physics aren't accidental, but deliberately set. Critics push back, insisting nature doesn't need a programmer to explain its order. Yet the parallels keep stacking up. Even black holes, those cosmic data shredders, might have event horizons that encode information like a hard drive's storage limit. If the universe is computing itself, it raises a dizzying question: who or what wrote the original code? Whether you see this as metaphor or metaphysics, it's a striking lens on reality. The universe might not just follow rules, it could be built from them, one quantum calculation at a time. Gravity keeps your feet on the ground and planets in their orbits, but compared to other fundamental forces, it's shockingly feeble. A tiny magnet can lift a paperclip, effortlessly defying Earth's entire gravitational pull. So why is nature's glue so weak? One radical idea flips the script. Gravity might not be weak at all. It could just be leaking. Picture a garden hose spraying water through a sieve. Most of the water escapes through the holes. What's left is just a trickle. That's the essence of this theory. Gravity could be seeping into hidden dimensions beyond the four we experience: space, time, and the three spatial dimensions we know. While electromagnetism and nuclear forces stay confined to our familiar reality, gravity might be spreading outward, diluting its strength across unseen realms. This isn't just wild speculation. String theory, the framework aiming to unify all physics, requires extra dimensions, up to 11 in some versions. These dimensions could be curled up incredibly tiny, like rolled-up socks stashed in the fabric of space, invisible to us but accessible to gravity's reach. Experiments at particle colliders like the LHC have hunted for signs of these hidden dimensions, looking for energy losses or mysterious particles that might wink in and out of existence. Even cosmic phenomena hint at the possibility. Black holes, for instance, emit radiation in ways that suggest gravity behaves differently at quantum scales, almost as if part of it is slipping away. If true, this would mean our universe is just one slice of a far richer, multi-layered reality, with gravity acting as the faint echo of something much grander. Skeptics argue there's no direct proof yet, but the math holds tantalizing potential. Whether gravity's weakness is a cosmic quirk or a clue to deeper dimensions, one thing's clear: the force we take for granted might be hiding the universe's biggest secret, just out of sight. Deep in the cosmic void, hidden behind the Milky Way's dust and stars, something massive is pulling entire galaxies toward it, including our own. Astronomers call it the Great Attractor, a gravitational anomaly so powerful it bends the motion of thousands of galaxies like a cosmic whirlpool. But here's the catch: we can't see what's doing the pulling. This mysterious region, sitting about 250 million light-years away, defies easy explanation. At first, scientists thought it might just be a colossal supercluster of galaxies, their combined gravity tugging everything inward. Yet when they mapped the area, the numbers didn't add up. The mass was far greater than visible matter could account for. That leaves two spine-tingling possibilities. Either our understanding of gravity is wildly incomplete, or something even stranger lurks in that direction. Some theorists suggest the Great Attractor might be a rare space-time defect, a kink in the fabric of the universe left over from the Big Bang, warping gravity itself. Others speculate it could be a portal to another cosmic structure beyond our observable horizon, dragging us toward an unseen supermassive presence, the most radical idea. It might not be matter at all, but the fingerprint of an entirely new force or dimension bleeding into our reality. Here's why this matters. If the Great Attractor is more than just a cluster, it could rewrite the rules of cosmic motion. Galaxies aren't just drifting apart, they're also being herded by invisible shepherds, and we're caught in the flow. Future telescopes, like those peering through the Milky Way's obscuring veil, may finally reveal what's hiding in the darkness. Until then, one thing's certain: the universe is playing a gravitational game, and we're just starting to learn the rules. Imagine the universe expanding not just as empty space stretching, but as something alive. Galaxies drift apart not because of some impersonal force, but because a higher dimensional entity is breathing us into existence. That's the spine-tingling premise behind this theory. Dark energy, the mysterious force accelerating the universe's expansion, might not be a force at all. It could be the sigh of a being so vast, so alien, its very breath warps the fabric of our reality. Here's how it works. In our three-dimensional world, we see dark energy as an invisible push, a cosmic repulsion driving galaxies apart. But if you could step into a fifth dimension or higher, that same energy might look entirely different. Picture a higher dimensional creature exhaling, its breath rippling through lower dimensions like wind inflating a balloon. Our universe isn't just expanding, it's being inflated from the outside. This idea isn't pure fantasy. It ties into cyclic cosmology, the theory that universes undergo endless cycles of expansion and contraction, big bangs followed by big crunches. Some versions suggest these cycles are driven by higher dimensional physics, where each breath of a multidimensional being spawns a new universe. It's called the Big Bounce, collapse, rebirth, repeat, an eternal cosmic heartbeat. The math gets wilder. String theory allows for higher dimensions curled up so tightly we'd never perceive them directly, but their influence could seep into our reality, manifesting as phenomena like dark energy. If true, it would mean the fate of our universe, whether it keeps stretching or collapses back, might hinge on the rhythms of something we can't even comprehend. Skeptics, of course, argue this veers into metaphysics, but the beauty of science is its willingness to chase the unimaginable. Whether dark energy is the breath of a godlike entity or just an unexplained physics quirk, one thing's certain: the universe feels less like a machine and more like a living, breathing thing. And if that's true, what else might be out there watching, waiting, exhaling? In the vast emptiness between planets, two little spacecraft, Pioneer 10 and 11, quietly defied the laws of physics. Launched in the 1970s, these probes were supposed to glide smoothly through the cosmos, bound by the predictable tug of gravity, but something strange happened. As they drifted beyond Saturn, scientists noticed a tiny but undeniable anomaly. The Pioneers were slowing down just slightly more than equations predicted. At first, it seemed like a rounding error until it kept happening mile after mile, year after year. This was the Pioneer anomaly, a cosmic whisper hinting that our understanding of reality might be missing a page. The discrepancy was minuscule, less than a billionth of the acceleration you feel from Earth's gravity, but impossible to ignore. For decades, explanations ranged from mundane to mind-bending. Maybe heat radiating unevenly from the probe's power systems nudged them off course, or perhaps it was something far stranger, like an unseen halo of dark matter clinging to the solar system, dragging on the probes like cosmic molasses. Then there's the radical possibility: what if gravity itself behaves differently at the edge of our cosmic neighborhood? Modified gravity theories like MUND suggest Einstein's equations might need tweaking in the weak, sprawling outskirts of space, places where gravity's pull is barely a whisper. If true, the Pioneer anomaly wasn't a glitch, it was the first clue that our cosmic rulebook is incomplete. But in 2012, the mystery seemed to solve itself. Meticulous analysis pointed to an unexpected culprit: thermal radiation. As the probe's plutonium power sources decayed, heat bounced off their antennae asymmetrically, creating just enough recoil to match the anomalous deceleration. Case closed, not quite. Some scientists still argue the numbers don't fully add up, leaving a crack in the door for wilder ideas. Could there still be undiscovered physics lurking in the deep, or was this just a brilliant lesson in how easily the universe can trick us? Whether the answer lies in heat, hidden matter, or rewritten laws, one thing's certain: the Pioneers reminded us that even the quietest corners of space can hold the loudest surprises. And the next anomaly might not be so easily explained away. In October 2017, astronomers spotted something streaking through our solar system that didn't belong. A mysterious, cigar-shaped object hurtling past the sun at nearly 200,000 miles per hour. Named Oumuamua, Hawaiian for scout, it was the first confirmed visitor from another star system. But the more scientists studied it, the stranger it became. Instead of slowing down as expected, it inexplicably sped up, as if propelled by an unseen force. Harvard astrophysicist Avi Loeb raised a jaw-dropping possibility. What if Oumuamua wasn't just a rogue space rock? Its bizarre acceleration couldn't be fully explained by outgassing the usual culprit for speed changes in comets. There was no visible tail of gas or dust, and its peculiar shape, 10 times longer than it was wide, defied natural formation. Loeb suggested something radical. Maybe it was artificial, a light sail perhaps, a thin, reflective spacecraft pushed by starlight, sent by an advanced civilization to explore the cosmos. The scientific backlash was swift. Mainstream astronomers argued that unusual doesn't equal alien. They pointed to possible exotic ices evaporating invisibly, or even hydrogen ice, a substance that could explain the acceleration without leaving a trace. Others dismissed the idea as sensationalism, insisting extraordinary claims require extraordinary evidence. Yet the debate highlights a deeper truth. Oumuamua didn't just challenge our understanding of interstellar objects, it exposed how little we truly know. Whether it was a natural oddity or a relic of alien engineering, its fleeting visit reminded us that the universe is full of surprises, and the next scout might not be so silent. Hold onto your history books, because what if nearly 300 years of the past never actually happened? This is the phantom time hypothesis, a theory so audacious it claims entire centuries were invented out of thin air. According to this idea, the period between 614 and 911 AD, including the reign of Charlemagne and the rise of the Holy Roman Empire, might be nothing more than an elaborate fiction, inserted into the timeline by medieval rulers and scholars. The theory hinges on eerie gaps in the historical record. For those 3 centuries, surviving documents are suspiciously scarce, and what does exist often repeats familiar narratives or contains glaring inconsistencies. Even architectural and archaeological evidence from this era seems oddly thin, as if someone forgot to fill in the details. Proponents argue this isn't coincidence but proof of a deliberate cover-up, a fabrication designed to extend the calendar for political or religious control. How could such a colossal deception happen? Imagine a powerful emperor or pope ordering scribes to rewrite history, adding phantom generations to dynasties, or inventing entire wars to legitimize their authority. With few people literate and no way to verify dates across regions, the lie could have spread unchecked. Even the Gregorian calendar reform in the 16th century might have been part of the ruse, subtly locking the false timeline into place. Of course, mainstream historians dismiss this as fringe fantasy. They point to tree ring data, eclipse records, and Chinese astronomical observations that align with the traditional timeline. But the phantom time hypothesis forces us to ask a haunting question. How much of history is fact, and how much is just a story we've agreed to believe? Whether you buy into the idea or not, it's a gripping reminder that the past isn't always set in stone. It might just be written in sand. Black holes don't just swallow matter, they might be erasing the very fabric of reality itself. At the heart of this cosmic conundrum lies the black hole information paradox, a puzzle so profound it threatens to unravel our understanding of physics. Here's the problem. According to quantum mechanics, information can never truly be destroyed. Every particle, every interaction leaves an indelible mark on the universe, a permanent record of existence. But black holes defy this law. When something crosses the event horizon, it vanishes without a trace, as if the universe hits the delete button. Enter Stephen Hawking's groundbreaking revelation: black holes aren't entirely black. They slowly leak energy, Hawking radiation, faint particles escaping over eons until the black hole evaporates entirely. But here's the catch: that radiation appears random, carrying no fingerprints of what fell in. So where does the information go? If it's truly lost, quantum physics collapses. If it's preserved, how? One radical solution suggests black holes aren't the smooth, space-warping pits we imagine. Instead, their event horizons might be fiery walls of chaos, firewalls of searing energy that obliterate anything touching them. Think of it as a cosmic shredder, reducing matter to scrambled data before it even enters. Others propose the information gets smeared across the horizon like a hologram, encoded in ways we can't yet decode. But the wildest idea, black holes might not be the end. They could be portals to new universes, with the ingested information reborn as the seed of another reality. Each possibility bends the rules of physics, forcing scientists to confront an unsettling truth. Either our laws are incomplete, or black holes are hiding secrets that redefine existence itself. Whether the answer lies in holograms, firewalls, or something beyond our current math, one thing's clear: the universe's darkest objects are also its greatest teachers. And the lesson they're offering might rewrite reality as we know it. Galaxies drift apart as the universe expands, but not all of them. Some move together, pulled by an invisible current that defies explanation. Astronomers call it the dark flow, a mysterious river of motion dragging thousands of galaxy clusters toward a single point beyond the edge of everything we can see. What's out there, and why is it tugging on our cosmic neighborhood? This isn't just random drift. When researchers mapped the motion of hundreds of clusters, they found something unsettling. A collective movement too fast and too uniform to be explained by known gravitational forces. It's as if something massive, something outside our observable universe, is exerting a pull stronger than anything we've ever detected. The scale is staggering. This unseen attractor would need to be billions of times more massive than the entire Milky Way to have such reach. One spine-tingling possibility: the dark flow could be evidence of neighboring universes brushing against ours. In the multiverse hypothesis, other bubble universes might exist just beyond our cosmic horizon, each with its own physics and structure. If one of these bubbles grazed ours, its gravity could ripple inward, nudging galaxies like leaves in a current. Think of it as cosmic magnetism, an invisible hand from another reality reaching through the void. Skeptics argue it could just be an immense supercluster lurking in the shadows, obscured by interstellar dust. But even then, its sheer size would rewrite our understanding of cosmic structures. Others suggest it's a flaw in our measurements, a trick of perspective. Yet the data holds firm, leaving scientists with a haunting question. If the dark flow is proof of other universes, what else lies beyond the edge of the unknown? For now, the mystery lingers, but one thing's certain: the universe isn't just expanding. It's being drawn towards something we can't see, something that might rewrite the story of everything. Look closely at a snowflake under a microscope, and you'll see intricate patterns repeating in perfect symmetry, tiny branches mirroring the whole. Now zoom out to the cosmic scale, and something eerily similar emerges. From the branching veins of a leaf to the sprawling tendrils of galaxy clusters, nature adores repetition. This isn't just coincidence, it might be the universe's hidden blueprint. If reality is a fractal, then every thread of the cosmos, no matter how vast or minuscule, could be echoing the same endless pattern. Take galaxy filaments, those colossal threads of matter stretching hundreds of millions of light years across the void. They don't sprawl randomly, they twist and split like roots of a cosmic tree, mirroring the structure of neurons firing in a human brain, even more uncanny. The distribution of matter at the grandest scales resembles the fractal branching of river deltas or lightning bolts. It's as if the universe is running the same code at every level, from the quantum to the galactic. Some scientists take this further, suggesting the fractal nature isn't just aesthetic, it's fundamental. If the universe endlessly repeats its patterns, there might be no true, smallest or largest scale. Zoom in far enough and you'd find miniature universes nested inside particles. Zoom out and our entire cosmos might just be a speck in some greater structure's fabric. This idea turns the Big Bang inside out instead of a singular beginning. Reality could be an infinite recursion, a hall of mirrors where every reflection contains another world. Of course, skeptics argue that apparent similarities don't prove a deeper connection. The math of cosmic expansion and galaxy formation might just favor certain shapes by accident. But if the fractal theory holds, it rewrites our place in existence. We're not just living in the universe, we're woven into its endless, repeating tapestry, one thread in an infinite design. Whether pattern or profound truth, one thing's certain: the cosmos loves an echo. Here's a chilling thought: what if death is an illusion your consciousness refuses to accept? That's the unsettling premise of quantum immortality, an idea so bizarre it turns survival into a cosmic glitch. Picture this: every time your life hangs in the balance, reality splits. In one timeline, you perish, but in another, you narrowly escape. Your consciousness, like a passenger on a runaway train, keeps leaping onto the surviving track, oblivious to the versions of you that didn't make it. This isn't just sci-fi. It's rooted in the same quantum weirdness behind Schrödinger's famous cat, the thought experiment where a feline in a box is both alive and dead until observed. Apply that to human experience. If every quantum possibility spawns a new universe, then somewhere out there, a version of you always survives. Car crashes, illnesses, even old age. Your awareness might just be hopping timelines, forever dodging the Reaper. Critics call it solipsism gone wild. After all, if consciousness can't experience its own end, how would you ever know? Supporters counter with eerie near-death accounts, people who swear they should have died but inexplicably didn't. The math at least doesn't rule it out. In an infinite multiverse, there's always a world where the bullet misses, the heartbeat restarts, the parachute opens. Whether it's a profound truth or a psychological sleight of hand, quantum immortality forces a spine-tingling question. Are you truly immortal, or is the universe just really good at hiding your corpses? Venus isn't just Earth's fiery twin, it might be a cosmic graveyard hiding secrets we've barely begun to uncover. While today's scientists see a hellscape of crushing pressure and acid rain, Cold War-era Soviet researchers floated a startling idea. What if those scorching plains and jagged highlands aren't just natural formations? What if they're the ruins of something else? Decades ago, when Soviet probes like Venera began sending back the first hazy images of Venus's surface, some analysts noticed strange geometric patterns in the rocky landscapes. Towering plateaus with unnaturally straight edges, clusters of symmetrical structures, even what looked like massive, crumbling arches. To a handful of researchers, these weren't just wine-sculpted oddities. They were potential artifacts of a lost civilization, one that perhaps thrived before Venus's runaway greenhouse effect turned it into an oven. Mainstream science, of course, scoffs at the notion. Modern orbital scans reveal those structures as nothing more than volcanic formations, shaped by millennia of extreme heat and tectonic chaos. The planet's surface is young, geologically speaking, constantly resurfaced by eruptions, leaving little chance for ancient ruins to survive. And let's not forget the surface temperature hovers around 900 degrees Fahrenheit, hot enough to melt lead, and hardly hospitable to any known form of life, past or present. Yet the conspiracy persists, fueled by tantalizing gaps in our knowledge. We've mapped more of Mars than Venus, thanks to its thick, radar-scattering atmosphere. Could there be pockets of the surface hidden beneath those eternal clouds that tell a different story? Some fringe theorists even speculate that if a civilization did exist there, it might not have been carbon-based like us. Imagine silicon life forms thriving in extreme heat, their biology as alien as their architecture. Whether you see this as fringe fantasy or a cautionary tale about cosmic hubris, the Venusian mystery lingers. Maybe the ruins aren't physical at all, just shadows cast by our own imagination, a reminder that even in our own backyard, the universe still has the power to surprise. What if the universe didn't just begin? What if it bootstrapped itself into existence? This is the mind-warping idea behind the time-traveling universe theory, where the Big Bang wasn't a spontaneous explosion, it was a cosmic message sent from the future. Imagine a civilization so advanced they cracked the code of reality itself, manipulating time to ensure their own creation. In other words, we might owe our existence to our own distant descendants. Here's how it works. In physics, a causal loop is a paradox where an event becomes its own cause, like a time traveler going back to inspire their younger self, creating a loop with no clear origin. Now scale that up to cosmic proportions. If a future civilization discovered how to send information energy, quantum states, even the recipe for a universe backward through time, that data could trigger the very conditions needed for their reality to emerge. The Big Bang wouldn't be the start, it'd be the echo of a future act of creation reverberating across eons. This isn't just philosophical musing. Some interpretations of quantum mechanics allow for retrocausality, effects preceding causes. Experiments with entangled particles already show how quantum events can seem to know their future states. And if the universe's fundamental constants are suspiciously fine-tuned for life, could that precision be the signature of deliberate engineering from the far side of time? Skeptics, of course, balk at the notion. Time loops violate our intuition about cause and effect, and there's no direct evidence of futuristic meddling in quantum foam. But the theory forces a thrilling question. If the universe can self-create, does that make it the ultimate example of destiny, or the ultimate act of free will? Whether you see this as elegant symmetry or circular reasoning, one thing's certain: reality just got a lot harder to pin down. From simulated realities to cosmic graveyards, we've journeyed through 25 of the most astonishing theories that blur the line between science and science fiction. Each one challenges the very foundations of what we think we know, whether it's black holes birthing new universes, time folding back on itself, or the unsettling possibility that our entire existence might just be a glitch in some grander design. These ideas don't just stretch our imagination, they force us to confront how much of reality remains uncharted. So here's the big question: which of these theories shook your understanding of the cosmos the most? Was it the holographic universe where 3D reality is just a projection? Or the eerie zoo hypothesis suggesting we're being quietly observed? Maybe the fractal nature of existence where patterns repeat infinitely left you seeing the world differently. Whatever it is, let's keep the conversation going. Drop your favorite in the comments below. And don't forget to hit subscribe for more deep dives into the mysteries of the universe. Because here's the thing, science isn't just about answers. It's about asking better questions, daring to wonder, and embracing the awe of the unknown. So stay curious, keep questioning, and remember, reality is far stranger than we've been taught to believe. Thanks for joining me on this cosmic ride. See you in the next one.